What if I told you, no matter how powerful your engine is, no matter how advanced your tech becomes, no matter how aggressively you mash the accelerator, we will never outrun light. Not by 1 mile per hour, not by 1 inch per century. You just can't. Light has a speed limit, and it's not a suggestion. Or is it? Let's check that. Most of us grew up thinking light is just really fast stuff, like a very enthusiastic object. You turn on a flashlight, the light just shoots out, like tiny glowing pellets with great cardio. But how fast is light, actually? Well, 186,282 miles per second. That's per second, or about 671 million miles per hour. If you could drive that fast, you could circle the Earth more than 7 times in a single second, which would definitely void your warranty. Okay, so in our everyday world, speeds typically combine, right? If I throw a baseball at 30 miles per hour from a truck going 60 miles per hour, the ball is moving 90 miles per hour relative to the ground. That's just how speed works, right? Well, let's test it. All right, picture this. Our good boy Newton is running along happily with a small lamp hanging around his neck. He is moving forward. The lamp is on. Light is shining. Let's say Newton is running at 10 miles per hour, and the light from the lamp moves at 671 million miles per hour. Then the light should move at 671 million and 10 miles per hour to account for Newton's 10 miles per hour, right? That's what intuition says. But no, the light still only travels at 671 million miles per hour. Now let's put Newton in a car. Maybe 10 miles an hour is just too slow to really notice a difference in such a large number. So the car is going 60 miles per hour. He still has his lamp. The car is moving, the dog is moving, the light is moving. Surely now the light is going faster, right? Nope, still. The light only travels at 671 million miles per hour. Okay, fine. Let's escalate. Let's put Newton on a jet. Same outcome. What if we strap Newton to a rocket? The rocket accelerates faster, faster. 90% the speed of light. 99%. 99.9%. Newton's doing great, by the way. Very brave. Very good boy. The lamp is still on, and the light leaving that lamp is still traveling exactly the speed of light. Not faster, not slower, exactly the same. 671 million miles per hour. No matter how fast Newton moves, no matter how fast the rocket moves, light refuses to stack speeds. This is where reality just stops behaving. In normal life, speeds add. Throw a ball on a moving train, speeds add. Walk forward on a moving jet, speeds add. But light is not a baseball. Light is not a car. Light is not even really stuff in the way we think of stuff. In the late 1800s, scientists assumed light moved through something called the luminiferous ether. Basically, it was invisible space jelly. They thought light needed a medium to move through. So if Earth was moving through that medium, we should detect a difference in light speed depending on the direction we point the light. Enter the famous experiment by Albert Michelson and Edward Morley. They measured light very carefully. In multiple directions they measured light, expecting to find variation. They found nothing. Light's speed was constant in every direction. No ether wind, no variation, just the same number. The result broke physics. Eventually, a patent clerk named Albert Einstein looked at that and said something wild. What if the speed of light is the same for everyone, no matter how fast they are moving? Instead of light adjusting, time and space adjust. Here's the part where things get uncomfortable. If you're moving very fast relative to someone else, your clock ticks slower. This is because you're using more energy to move through space, which leaves less energy for you to move through time. Motion through space and motion through time are linked, and the faster you move through space, the less you move through time. Meaning, if you could somehow reach the speed of light, all of your energy would be devoted to moving through space, leaving nothing to move through time. And time would literally stop for you. Not metaphorically, literally. The faster you move, the more time slows down for you compared to someone standing still. This is called time dilation. And lengths contract. Distances shrink in the direction of that motion. Reality flexes to keep light's speed constant. Not because light is stubborn, but because the structure of space-time, it has rules. The speed of light isn't just fast, it's a conversion factor. It links space and time together. It's built into the geometry of our universe, which sounds kind of dramatic, because it is. So if we can't reach it, can we get close? Now here's where it gets even more interesting. Scientists have accelerated particles to almost the speed of light at facilities like the CERN using machines like the Large Hadron Collider. Protons have been pushed to 99.999991% the speed of light. And that's not an exaggeration. They are unbelievably close, and yet never equal. Never over. Why? Because as an object with mass moves faster, its energy increases, which increases its resistance. Nothing with mass can equal the speed of light because of this. And the closer an object with mass gets to light speed, the more energy you must add to increase its speed even a tiny bit. It's not linear. It's brutal. At low speeds, push a little. You go faster. Near light speed, you dump in mountains of energy and you barely gain anything. To actually reach the speed of light, you would need infinite energy. Infinite. Which is physics' polite way of saying, nope. Why can light move at light speed? Because it has no mass. Photons, the particles of light, are massless. They are not accelerating up to light speed. They are born moving at light speed. There's no ramp up, no warm up stretch. They just go. For anything with mass, like you or me or a very brave lamp holding dog, reaching light speed would require infinite energy. And again, infinite energy is not available. Not even with a Prime account. The speed of light has consequences. It means no information travels faster than light. No signals, no instant communication across galaxies. It means if you look at a star that's 100 light years away, you're seeing it as it was 100 years ago. The universe has latency, a cosmic ping, if you will. And it means that if you somehow traveled near light speed, everything would just slow down for you. You could travel across the galaxy in your lifetime. But when you returned, thousands of years might have passed on Earth. You would have outlived everyone, which is impressive, but kind of socially inconvenient. Okay, let's bring back Newton. He's on a rocket. He's going 99% light speed. The lamp is on. From the rocket's perspective, the light leaves at the speed of light. From Earth's perspective, the light leaves also at the speed of light. Everyone measures the same number because space and time adjust so that they do. The universe protects that number, not by boosting light or slowing it down, but by reshaping reality around it, which sounds fake, except we've tested it over and over and over. GPS satellites have to account for time dilation. Particle accelerators confirm it. Experiments confirm it. Light doesn't stack speeds. Reality bends to maintain the constant instead. The speed of light is not just fast. It's foundational. It's not the universe's fastest car. It's the speed limit sign that defines the universe. And no matter how fast you run, no matter how powerful your rocket, no matter how determined your dog is, you're not outrunning it. And that's not disappointing, it's astonishing because it means the universe has structure, rules, consistency, and we figured some of them out, which is kind of incredible. So that's it for this episode of Let's Check That. I'm Will, and until next time, remember, curiosity is good. Verification is better.